Hello, developers. Welcome to another episode of Google Pay Live Integrations on Android. I hope you had a wonderful start into 2025. I'm Domi. I'm a dev rel for Google Pay. And in today's episode, we are going to integrate Google Pay with Jetpack Compose on Android. And to help me with that, as always, I have here with me my coworker, Jose. Jose, what are you up to? How did your year start?
Hey, Domi. Hello, everyone. It's really good to be here again. Well, I have gotten into 3D printing. What do you think?
Oh, 3D printing. To be honest with you, I never looked into it, but yeah, it's interesting. So what did you print?
It's a lot of fun. I'm renovating a part of my place, so I'm now crazy printing parts and adapters to make it look to make things look the way I would like them to look. So it's
right.
yeah, it's a lot of trial and error, but it's lots of fun. I need to show you around.
That's great. That's super interesting. Great. So yeah, Jose, today you will do live coding. Are you ready for that?
Finally, it's been a while that I've been waiting for this moment. So yeah, super happy to do it again.
Great. That's cool. All right, developers. As I said before, we are going to showcase you a live demo of the Google Pay API integration on Android using Jetpack Compose. Before I hand over to Jose, I want to ask you to please put all your questions in the chat, be it about Google Pay, be it about Google Pay on Android, payments in general. Make sure you use the chat, ask us questions. We try to pick as many as we can, and let's try to make this as interactive as possible. Also, in the video description, you will find a couple of links. Make sure to check them out. I want to quickly mention two of them. Once, give us a follow on X at Google Pay Devs is our account to get the latest and greatest updates around Google Pay. And finally, we also have a payments channel on Discord. If you have questions later on after the live stream or in the upcoming days and weeks, feel free to reach out on Discord and we help you with that. All right. Then I would say, Jose, if you're ready, you can take it from here.
Let's do it. So what are we going to do? We're going to integrate Google Pay on an Android application, as Tommy just said. There's multiple ways of doing that with Android. You can use Java, you can use Kotlin, you can do your UI and XML, you can use Jetpack Compose. There's many ways of doing it. We have done a few videos in using different approaches, but we wanted to take the opportunity to do one in which we use, let's say, maybe our preferred techniques, or the ones that we think are the most powerful. And that is going to be today with Jetpack Compose and coroutines.
Nice.
So
sounds good.
We will start with an application that has a really simple checkout form, and we're going to add Google Pay to it. So let me fix it to run it first, just so that you see how it looks like. We have some stranded imports in here. Let's see if I can get rid of them. Plenty. Oh yeah, I can see this.
All right.
That's because I don't have a library integrated. Not sure if it's worthwhile going through this now. Let me just try a couple more, and then I can show you the app, how it looks now. It's not very important, but then you can get a sense on what we're trying to do. So we have a really simple application. It's our usual that you probably, if you've been following us, you have seen a few times, our t-shirt shop. So we have a mobile application. We sell polo shirts and t-shirts. And as you can see, this is a simple checkout form, checkout screen. We have a pay button that will typically take us to a form that users have to fill out. We want to integrate Google Pay to simplify that checkout process for your users. So we're going to do it step by step. Again, Jetpack Compose and coroutines. Take this opportunity to compare this with your checkout screens in your applications. And then, if you have any questions or if you have any ideas, drop them in the chat and we can discuss them. Remember that this is live, so it probably gives you an opportunity to interact with us.
Yeah, Jose, actually, let me ask you a question. So if I want to get started with a similar demo application, let's say, we provide something open source, right?
We have a repo that we are using in this example as well. It's in GitHub. It's called Android Quick Start. We can probably share a link at some point, but you can find it very easily. It's under the Google Pay org in GitHub. You have multiple flavors of this application, as the same way as we're doing now with Jetpack Compose coroutines. We have also an example for Java, for callbacks, and so on and so forth. So it will match what it will very likely match what you have already in your stack. So why don't we go ahead and start by importing the Google Pay library for Android. It's actually my first time or second time using, how is it called? It was called Library Bundle or something like that. That's not the right name. But basically using this Libs versions TOML, version catalog. That's how it's called.
Do you like it? Do you like it compared to the previous, dependency management in Android Studio?
It's a bit more work to get things going, but it's more organized. So what that says that for simple projects, still use like Gradle just off the bat. But if I have like a more complex project like this one, then I like how things are organizing here.
Okay. Yeah, makes sense.
Especially if you have like multiple packages from a specific library, you don't have to retype the version multiple times. So I think that makes it easier. So I'm importing the Google Pay library, and that's Play Services Wallet, I think. And the version ref is going to be Google Pay API. And then I need to reference back in the top in the versions. This is not a video about the version catalog. There's probably a few of those that you can see, but I'll still try to talk through it as I go. So I think that's 19.40, right, Dominik?
That's correct. Yes, that's the latest version.
And what about also taking the chance to import the Compose button?
Oh, I love it. That's great. That's a great idea.
Okay, let's do that. And that's something like Google. Oh, too many O's. Pay button Compose. I'm not sure. I'll need to look it up. Is it like that?
Yes.
Okay. Then I'll trust you and go back to the studio.
Oh no, actually, I thought that you were asking if you typed the right Google query. So maybe go back and quickly check on GitHub what the dependency is.
All right. Compose Google Pay button. Compose Pay button. Easy enough.
Yeah.
Compose Google Pay button. Name.
While you are typing the dependencies, we can quickly take a question from Manish. So Manish is asking, your design for a Google Pay button is limited. Can you provide more flexibility? Actually, we do provide certain configuration like theming and border radius, black and white, and different types of the button. So you would need to tell us why are you limited? Like, what would you like to have in order to further customize the pay button? If you could drop an answer in the chat, that would be great.
Yeah, what do you need, Manish?
Yes.
Right now you can do a lot of things. All right, now I go to my modules, build Gradle. And now, actually, and this is very cool, you get the autocomplete directly from the version catalog. So that makes it easier to manage. So I've imported both the Google Pay API dependency and the Compose button dependency. So that's all fine. So now the Google Pay integration can be thought of as 3 steps. The first one is checking whether your users using your application can use Google Pay. And it might be that they can use it or for various reasons, like, for example, because they don't have a valid payment profile in their accounts ready, or because they are operating in a country where there's no PSP support for Google Pay, it might not be available. So the first thing you need to do is check whether your user can pay with Google Pay, which is what we're going to do next. Second step, if the user can pay with Google Pay, then you can go ahead and launch the payment selector so that your users can select a form of payment and complete the payment. The third step is send that information, the encrypted payment information coming from Google Pay, to relay that to your PSP to complete the transaction. The third point we are not going to do today. We have multiple live streams and videos covering that topic, and since today we wanted to keep it PSP agnostic, we're going to focus just on the implementation part on the client side. So as I just said, first.
However, Jose, if you have ideas, like talking to you developers, if you have ideas or you want to see content for a specific Google Pay content for a specific PSP, please let us know in the chat. As Jose just mentioned, in the last couple of years, we did multiple live streams together with PSPs, but maybe you're missing one. So let us know in the chat.
Okay, so we're following a MVVM architecture because we find it convenient and powerful, also because it's what the Android guidelines are like advocating for. And for this video, we will agree about that. So we have a view that is built on the activity, that is built with Jetpack Compose, and we have a view model, so you can see here. So operations like background tasks, checking whether users can use Google Pay, we'll do here. We need to tell the UI about that at all. So the first thing I'll need to do is every single call that we do against the Google Pay API will be done through the payments client. Think of it as a HTTP kind of client that will help you call the Google Pay servers. So let's start with that. Let's create a variable called Pay Client, and that's going to be a payments client. And one of the classes in the Google Pay API, it's the wallet class, has a method called getPayments client that takes two things for us: a context or an activity. We're going to take the application context that we get on our view model, and then a list of options, configurations for your client. We're going to keep that very simple for now. So the context is going to be the application, and the wallet options we're going to build with a builder, and we're only going to set the environment to, what do you reckon, Domi? Test or production for now?
Well, test.
Test.
If you would put production, we would need to go through the onboarding stuff in our Pay and Wallet console. And for the sake of this live stream, I think it's easier to use test.
Nevertheless, if you're interested in seeing Domi's credit card getting depleted on production, just add your votes in the chat so we can record another episode, maybe operating on production, if Domi is happy about that.
Yeah, that's actually not a bad idea. Once doing a live stream and doing an actual productive integration by actually charging a card, that would be super fun. However, we would need to somehow manage to not show the actual credit card number, but I think that would be possible and would be super fun.
All right, we could find a way.
Yeah,
great.
Sure.
We have the client. Let's make the call to check whether Google Pay can be used. Just say something like verify Google Pay readiness. What a cool name for a live stream, Domi. I normally need more time to come up with a good name.
Yeah, just quickly, Jose, Manish answered and says that we only provide a certain styles of the button. I guess Jose, we can look into this later as well by configuring the button in various styles. Only light and dark themes for the button, and also the text is standardized like buy with Google Pay. Yes, that's correct. However, as you know, and you wrote that already in your second comment, you can also use different types, buy, donate, checkout, and order, and so on and so forth, to change the text of the button. But yes, you're correct. For now, we only support light and dark and light themes. Would be great if you can put another comment telling us what you would like what are your needs? How would you like to configure the button?
Great, thank you. So as you can see, the call that we want to make is ready to pay. So as you can see on the params, is ready to pay is taken and is ready to pay request param, and then it's returning a task. Tasks is an abstraction that Google Play Services uses to make remote calls and give you a result. So that's a common theme that you will see across Google Play Services libraries like Authenticate or Firebase and so on. So this ready to pay is asking us for an object that we don't have yet. So just create it. Let's create the request. And we're going to use a builder as well. Well, not a builder in this case exactly, because we're going to be deserializing from JSON. So we're going to take a configuration that we have in a utility class that I'm going to show you in a second, just because it's pure JSON that will take us a while to write, but I'm going to go through the fields now. So we have a request ready in the utility class that is called is ready to pay request. So you can see it's a JSON object, which is what this constructor takes. We're going to change it or convert it to a string. But basically, this is a really simple request that has the version number of the API that we're going to use in the Google Pay API. So using that, we are using 2.0 for this example. And we are setting a param called allowed payment methods that contains the type of payment, forms of payment that you accept in your application in this case. So for us, it's going to be just cards that correspond or conform to these card networks and auth methods. Domi, you want to say something?
Yeah. So what you theoretically could do in your own app, your own integration, is load this configuration server side. So then this would theoretically give you the power of say, if at the beginning you support all the cards, and then for whatever reason later on you want to turn off a certain network, you can do that server side. So it's very well possible to load all this configuration from the server side, and as you can see here, that's a list of the supported networks. And maybe at some point, for whatever reason, you want to turn off one of the payment methods. So then you could do that server side, and then the configuration gets loaded dynamically, and cards of your disabled network will no longer show up in the Google Pay sheet.
That's right. Nevertheless, if you do that, make sure to test before you go to protection to make sure everything works fine. So we are configuring networks. In this case, we're supporting American Express, Discover, JCB, MasterCard, and Visa. There's also a param called auth methods. You want to briefly talk about this, Domi? I feel you explained this better than I do.
Yeah. So as Jose said, next to the supported networks, what's super important for you to consider is by specifying the supported methods, which can be either PAN only or cryptogram 3DS. So PAN only, if you put PAN only into the list, this means you are accepting playing cards. So for example, cards coming from autofill things like that. And the second one, cryptogram 3DS, is you're telling Google Pay that you want to accept tokenized cards. Those are the cards a user tokenized, which means that the user actually added the card and tokenized it through the Google Wallet application. So as an example, you can say you want to accept both, but you can also say, you know what, I only want to accept tokenized cards, and then you only put cryptogram 3DS as the value.
Great. So with that, we have our request ready. So we can call is ready to pay with the request. Now, typically, this would return a task that upon completion, it will give you a result, in this case, true or false. The user can pay with Google Pay or not. But this is an asynchronous task. So what the task API exposes is a set of callbacks, as you can see here, autocomplete listener. Now, we said that we're going to use coroutines for this example. So we would want to find a way to turn this task into a coroutine. And for that, there's a great library. By the way, I don't know who builds it, I think it's our team internally that builds kind of a glue that turns the task, the synchronous task itself, into a suspendable function that you can use as a coroutine, obviously. So I always look for it as play services task interoperability. It takes you right away there. This is another public open source repo that you can use, explore the source code as well. And as you can see, they have a list of, let's say, glue interfaces between frequent or popular asynchronous libraries like Wava or like ArcJava. We are interested in coroutines. So this is the one that we want to import. Again, just so that we can use tasks in the scope of coroutines on Kotlin. So let's go back to our catalog. Now I'm definitely getting my practice on this, Dominik. By the end of this live stream, I'll know how to do this.
Is that the last dependency we need, or we need more?
It's the last one, right?
Just asking.
It's a long process now, but I think I really like. It's satisfying to have these things kind of sorted in one place. To be honest.
While you're typing yet another dependency, let me take another question. What are the benefits of the live chat? That's a very good question. Just feel free and ask your questions you want to get answered. Again, around Google Pay on Android, around payments, please feel free to use the chat. But again, you can also join our Discord payment channel to ask questions over there.
What was the question about? I missed it.
What are the benefits of live chat?
Oh, I see. Of this live chat?
I guess so, yeah.
Okay. Well, you can ask Domi everything that you need to related to the Google Pay API or not. Or would you accept questions that are unrelated to Google Pay, Domi? That's a question to ask.
Yeah, sure. I guess questions around Android, Compose.
Good. So now that the library is included, we sync Gradle once again. We're syncing Gradle once so that it builds the version catalog. And then when we import it in our modules build Gradle, then we have to sync Gradle again so that it fetches the dependency. So now what we should see is, and we're not seeing, is an await method in here that will turn this task into a coroutine. Let's see why that's the case. Oh, I see why. Because we have some typos in here. Classic.
We do? I did not see it.
I was expecting you'd be looking to me.
I did.
All right, fair enough. Great. So if this imports fine now, then we get the await, and now this is a suspended function. So what we can do is going to return the result directly, right? So that's a Boolean instead of a task. So with the Boolean, we can already decide what to do. What we're going to do is, because since this is an application that's using Jetpack Compose, we're using the unidirectional flow to update the UI. Yep. That is, we have a state, payment state, that we're updating every single time there's a change. And this is triggering a recomposition, right? So this payment UI state, just to go quickly through it, has a few states that refer to the payment flow. That is, the payment hasn't started, Google Pay is available, as you can see in the second line, payment is completed, or there was an error. So what we're going to do, based on the result of the is ready to pay call, is we're going to create a new state. And we're going to try this call because, again, this could fail with an API exception. So we want to make sure that we capture that. And if the result is successful, then we're going to say, okay, we're good. So the new state is going to be payment UI state available. And if it's not, then it's going to be payment UI state error. And we're going to fail with the common status code error. You may want to get more deeper in here in your application based on how you want to react if Google Pay is not available. You may want to show other forms of payment or just your regular checkout form. If the call fails, then we want to issue another error. This time we're going to include the status code on the exception. So we have more information on the UI if we need to do that. Finally, we're going to update our state with the new state that we created. Okay, so what this is going to do is going to create that recomposition. It's going to redraw our layout with the result. So
awesome.
Last thing that we need to do before is we need to launch this. So we need to verify Google Pay readiness. And for
developers watching, what Jose is currently working on is a Google Pay integration on Android by using Jetpack Compose. Once again, if you have any questions regarding Google Pay payments, Jetpack Compose, please let us know in the chat.
Great. So now I'm back to the layout, and we have an if in here that it was already strategically placed. I don't know who put it in there. That says that if our pay UI state is better than available, that is, if it's available or payment completed, we would want to show the Google Pay button. That means that we have gone through this ready to pay call, and now we are ready to show the payment button.
Yes.
So for now, we're going to keep this really empty, and then that's going to take an allowed payment method as well. You may want to talk through this while I type it. Why do we need allowed payment methods on the button, Domi?
Yeah. So first of all, what's the pay button, right? This is coming from the Compose dependency we imported, correct?
Yeah.
Great. So yeah, the reason why on the pay button object, the allowed payment methods property is mandatory is to make sure that you define the right payment method. So for example, if you as a merchant, you only support Visa, MasterCard, but not American Express as an example, it's important to tell us that you only support Visa, MasterCard, and not American Express. If the allowed payment methods property would be optional, then the Google Pay sheet would show all the user's cards. So if the user has an Amex card, it would show it in the Google Pay sheet. However, you, for whatever reason, don't support Amex, that would be a problem. That's why we decided for this pay button object to make allowed pay methods a mandatory parameter.
Yeah, you see why I always prefer Domi's explanation, right? He always does a great job.
No, I mean, I also know your opinion. It's also my opinion about having smart defaults, right? We were in the team. We're thinking a lot about this. If we should make allowed payment methods an optional property, and because of the explanation I just gave, we thought let's go with a mandatory parameter.
Okay, so now what's happening is in the view model, we're checking whether the user is ready to pay. That's triggering a new state, which is landing on this line in the layout. And that state is available now. So we are entering this if condition, and now the pay button is shown. So that means that the user that I'm using on this device can use Google Pay to pay. Let's make it slightly bigger.
That would be great.
So that it
looks a bit off.
Yeah, so that it aligns with the rest of our UI. So we're going to fill the max width, and I think that'll look a bit better. Okay, so now the button is ready. The next step is clicking on the button to start the payment process.
Let me say one thing regarding the button, Jose, okay?
Go ahead.
You can see that right now, Jose, in the pay button object is not specifying the type, right? You're not specifying the type.
No.
Okay, cool. And the default type is the buy type. Maybe you can use the property quickly, Jose. You can see here we have all the different types: buy, book, pay, donate, checkout, and so on and so forth. And what you also can see on the button is the button shows your bank's logo and the last 4 digits. And this is done by using the buy button type. So when you're into the game of using the buy type, the Google Pay button will show your card's bank's icon and the last 4 digits. If you change it, maybe you want to change it quickly to maybe type equals checkout or type checkout.
And let's also do a theme, right? So that everyone sees
the
different. Let's do light, for example. And let's rerun this. It should look different.
Yeah, you can see now that Jose selected type checkout, which means the dynamic data, so the bank's icon and the last 4 digits of the card go away, because once again, they are only available for the buy button type as of now. And he changed to light, which makes the button white. Great.
Let's go back to where we were.
Yes.
But now again, clicking the button doesn't do anything, and that's because 199 is an empty line. The on-click is doing nothing. So we want to fix that. We are going to pass in the function for the click up to the color of the layout, because we want to launch the next step from the activity itself. And we'll get to that in a second. So for now, this is also, by the way, great practice because it makes your components stateless and more testable. So I'm just like making this component agnostic from the state. So I'm going to pass in the on Google Pay clicked callback all the way up. And I'm going to add it right in here in the on click of the pay button. So now the responsibility is on the caller, which is the activity. And we're doing this because the Google Pay button, the start payment process, needs an activity for result. That is a new activity, namely the payment sheet needs to show up. So that's going to run in a different activity. So we need to run this from the component activity, from the checkout activity that has a way to manage the new activity result APIs. So now it's asking for that param in the product screen because we're saying, hey, now I need the on Google Pay clicked callback, right? So what we're going to do is create a function that will start the payment. This is officially a method, in fact. And we're going to say, when I click the button, just start the payment process. This is going to be a suspend fun because we're going to be using coroutines. Are we actually? Let me just get to that in a second. All right. So a new activity is going to be started. So we need a way to capture that. To do that, if you haven't explored the new activity result APIs, I encourage you to do it, especially if you use the previous API, which, by the way, has been deprecated for 2-3 years or maybe more. So it's a good opportunity to update that. Also, it's a bit more intuitive, and the life cycle gets controlled or gets managed for you, so you don't have to worry about those weird and hard to debug memory leaks.
That's awesome.
Let's just create a payment launcher based on the contract that we need for the checkout activity. So we're going to register for activity result. This is part of the new activity class. So as you can see, this is asking, or this is taking a contract. There's multiple types of contracts depending on what you're doing. We built a few contracts to make this easier for you. So if you use, for example, the get payment data result contract, this is going to return directly a payment data response. So you don't have to process the intent, turn things into string, check for nulls. It's a bit easier. So
but I could if I would want to, right?
You can totally do it.
Yeah. So I could, as a developer, I could just implement my own contract, right?
Totally.
Yeah. Okay.
If you need to have more customization capabilities, then you can definitely do that. And this is going to return a result. We're going to get to that in a second. For now, we have the payment launcher that is ready to launch with this contract in here. This takes a task, the task that tells us what type of, what's our payment configuration. It's going to be similar to the is ready to pay. We're going to get to that in just a second. So again, we're going to use the pay client to make a second call. And that call is going to be called load payment data. This is the call that will start the payment process. And we're going to use a very similar configuration to is ready to pay to get everything started. So let's go to the view model, because this is where we are defining our, well, not private, it's going to be public, because we need to call it, or package private, no, actually public. We need to call it from the activity. We're going to call it start payment process. We're going to pass in price label. That is going to default to 00. This is the price that is going to display on the payment sheet.
Let's put a real price.
Yeah, let's not give it a default. Let's just make it mandatory so that you always have to pass it in. Great. So we're going to use the pay client again to make calls against the Google Pay API. And you can see that this time load payment data is taking a payment data request. So payment data request can be built as well from a JSON object, similar to what we did for the is ready to pay. And in this case as well, we also have a JSON object ready in the payments utility that we built before.
Great.
What price should we pass in? Let's use this for now, whatever comes to us. And we're going to turn into a string, and that will give us the payment data request. Great. Let's look at how this looks like to give you an idea, or maybe to show the differences with the Israel to pay call. In addition to the allowed payment methods, which are exactly the same as the ones we use for Israel to pay. In fact, we encourage you to use the same values because you wouldn't want to get inconsistent results when you're doing the Israel to pay call or the load payment data. You want those to be consistent. In addition to that, in here we have a few more items that are useful when it comes to when the time comes to make the actual request. For example, you may be needing shipping address from your users to know, because an item, in this case a t-shirt, needs to be shipped to a certain address. So we are saying that we require the shipping address. And now from the shipping address, we are interested in the phone number and some country codes where we are allowed to ship. So as you can see, few more configuration options that are useful when we are actually making the transaction. We are also going to have values for the countries and the currencies and the total price. The total price will show in the payment sheet when you're about to make the payment. Everything else is real similar. Let me go back.
Perfect. By the way, Jose, did you know that on top of the emulator you have a little out of date label next to a refresh icon? Do you see that?
Yes.
Can you click it quickly?
Yeah, I think I saw this like for the first time. I think it's the live updates. I just saw it a couple days back.
Yeah, because I was wondering when you change the theming for the button, live updates should actually work. But yeah, and now you change a lot of code, so maybe live update needs an actual restart of the app once more. But just changing the styling of the button should actually work with live updates.
That's correct. Oh yeah, because that's something that we are updating internally. So you should receive that information as it comes. All right, so we have all the information that we need. So we're going to return this back into the activity. So this is going to return, again, a task, remember, a object that holds the remote state for a call to Google Play services. And we're going to return that back to the activity where we are like handling that process. So let's go back to the activity real quick. We're going to say about task equal model. We said start payment process, right? And the price label, yes, that's something that you would want to define yourself at a specific point in time when the user has selected the actual item. Our recommendation is that you always fetch this price from your backend servers, from a source that you can trust. For now, for the purpose of this demo, we're going to say that the t-shirt costs 50.2, which is what we see on screen, by the way, right?
Yeah, makes sense.
Okay. Now that we have the task, we'll want to do two things. First, start it with the same library that we used before for the tasks API with coroutines, and then we're going to start the payment process with the launcher that we just created. So we're going to launch it with the task. You see that this launcher takes a load payment data task. You can see here, but if I do it again, you can see that it takes a payment data task, which is what we just created. Now we're missing something here, and that is the await method. We're going to be using for this load payment data task a different await method. We can get to that if you're interested. If so, let us know in the comments. It's really similar to the other one. Instead of returning the result of the operation, it returns the task itself.
Yeah,
it's an extension function that we created because it's useful for this purpose. If you're curious, let us know, and we can dive deeper into it. This is basically the code that was giving us trouble at the very beginning because we didn't have the library.
Oh, I see. Yeah, makes sense.
So now we should be able to await the task. And yeah, this is a suspend function. So what we want to do is call this from the lifecycle scope. And that's another very interesting read for you if you haven't looked into coroutines. I'm sure you have. But basically, a scope will be like a domain within where coroutines get executed that will be managed by the system depending on the life cycle. For example, this life cycle scope would attend to the life cycle of the activity, whereas the view model scope would be recycled, created, recreated, destroyed based on the life cycle of the view model, which is different. So you want to choose the one that is most suitable to the call that you're calling. In this context, what we are doing now is in the context of the activity itself, so the lifecycle scope is appropriate. Also, this is not running in the background. Remember the difference between a dispatcher and a scope. There's plenty of really good videos by the Android team on that. Since this task mostly runs as sequential UI-appropriate calls, we're going to keep that in the UI thread. But remember that scopes don't mean that you're running in the background. You will have to do that with playing with dispatchers as well. So quick summary. We are setting up the load payment data task, passing a price, which is 50.2, which is the cost of the t-shirt. And we're using the launcher that we created before, which is going to go over on the activity result, where the payment sheet is shown with the task that we just created. So if we kind of run this, the payment sheet will be shown and no result will be processed.
Curious now.
Okay, so that's the payment sheet. Now, so you can see, we have a card and we have a shipping address because we requested it. When we continue, that information is going to be returned back to us. Now, nothing is happening on our end because if you remember, this callback is empty. This task result, we are not processing it. So that's the last step in our integration process today. We're going to capture the results. And you remember when we said before that you don't have to do all this intent processing by hand, that we give you information to do it in a more seamless way. This is one example of that. You get the status directly from the object, and this already corresponds to API response status. So if everything went well, you can simply expect the success status, and that's going to have information about your payment. So we can, as an example, log the
token, right?
Result, the token, everything that we get back. In fact, we're going to log. Let's import these. And the information is included directly in the task result. So this is going to be a type payment data. So we're going to turn it into a string and see what comes up. In fact, we're going to need to turn it into a JSON object. Otherwise, we'll just get the memory representation. Okay, so that's it with that information. Oh, we have a little error here.
Yes.
Let's fix it. All right, so we want to, so the test result, we have it in here. And the status is, oh, of course, it's the status code that we need.
Yeah.
The status contains a code and a message. So if the information that we passed in is appropriate and the payment is successful, then we should see on the log card the outcome of the transaction. All right.
You can clear just clear it.
Yeah, I'm going to do something else, Tommy.
Okay.
Let's see if you see why. I'm going to remove this because right now I see an address that I can recognize. So let's maybe turn this back into false. And we're going to do the same thing with the billing address. And then avoid disclosing more than we want.
Sounds good.
Otherwise, we'll give a lot of work to our post-prod colleagues. Great. So I continue. And as you can see here, this is the result that we're getting back. So we get a response on the API version that we use, the card that we use, the details, and then the token is the field that you're interested in. We're using a payment gateway here. So because we are operating in tests, you get a sample token. When you operate in production, based on your PSP, you will get an encrypted payload with information that only your PSP can decrypt. So the last step, as we said at the beginning, is to send that to your PSP to complete the transaction. As we saw, this went through successfully. Now, one thing that you will need to do after that, which we're not going to do here because we are running out of time, I think, Domi.
We do.
Is covering all the other cases, right? So it could be a developer error because you have an issue in your integration, or a unrecoverable error. So you want to cover those and react accordingly.
All right.
Yeah, so this is the integration. Do we have questions?
Yeah, we have one more question we can take. Rayat is asking what considerations are required to support multiple currencies and regional payment methods for Google Pay. So if it comes to currencies, it's really important that you talk with your payment service provider first. Usually Google Pay supports a lot of currencies. There shouldn't be any limitation from our side if it comes to that. And if yes, your PSP will for sure reach out to us to sort things out. And if it comes to regional payment methods, yeah, that's an interesting question. So, for example, last year we launched Pix within Google Pay in Brazil. We launched BNPL, certain BNPL payment methods within Google Pay in the US. So we are always looking into what other regional payment methods we can support. Yeah, make sure to follow our channels to stay up to date on new regional payment methods.
Tommy, do we have 35 seconds to show the new error capabilities?
Absolutely. That would be awesome.
Great. So recently we improved our error tooling inside of the API. That's something that we heard from you, that you were looking for improvements there. So if there's an error now in your integration, you will see it in two places. You will get that error in the logs. We're going to see that in a second. But also, we have exposed that through the exception objects that you get programmatically. So you can explore those, and based on the error, make a decision, an informed decision on how you want to react. So we recommend you to look into them. I'll show an example on the is ready to pay request. So let me go real quick. Here, if we have an exception, I'm going to print the status message. And now we're going to play around in here in the configuration and break something. Oh yeah, the error would be a wrong place to do it. Let me leave that as it was. Let me break this first. Allowed card networks. And we are going to say that we support JCA, for example. That should be an invalid network. So let's log this error in here. And then see what comes out.
All right, let's see.
Good. Well, it's ready to pay worked fine.
Yeah,
I think I know why. I think we have modified the wrong object.
Yeah, probably.
No, we haven't.
No, then just add a random one.
Invalid. Net. Maybe it's the update behavior.
But yeah, JCA should actually also make
it
fail.
failed. Let me run from the beginning and see why this is working.
Yeah, can you do another another change in the payments util? Maybe not with the supported methods. Maybe we are allowing. Yeah, just exactly rename this property. Yeah, perfect.
No, but this should have failed. So I feel that we're just not capturing the state properly, I think. We need to do a quick debugging. Okay, so this actually made it fail. So as you can see here now, you're seeing the error saying the allowed payment methods is not valid in JSON format. It's not a valid param, and that's coming from the log that we are passing from the view model.
Great.
Is it though? I'm doing an information, but well, it's not that it's too important. But yeah, basically the bottom line is that you have now more information, more in-depth information about what's wrong, and that hopefully helps you troubleshoot your integrations more swiftly. In any case, let us know if this works for you. We hope it does.
Yeah, I think it's not coming from your log statement, so you're right. But yeah, I think it's clear that we did those improvements in terms of error handling, which will help. Oh, there we go. Yeah. Yeah, this is even more clear. So this helps you really a lot to get to the bottom of it if the request JSON is in a wrong format. Cool. Thank you so much, Jose. This was Google Pay Live integrations on Android. Once again, if you have any questions, if you want to chat to us, if you have questions about your Google Pay integration on Android, but also on the web, you can join the Discord channel, the Payments Discord channel. You'll find the link in the video description. Also, as I said at the beginning, give us a follow on X at Google Pay Devs is our account. And yeah, with that, thanks for watching, and until next time.
Bye.